Hi students, this is me Sarita Umesh. Welcome to my channel Fun Chemistry. Today we are going to learn a very interesting topic, that is modern periodic table. And this video will be useful for both class 10 and class 11 students. If you find my videos are useful, kindly subscribe it and press the bell icon so as soon as I upload a video, you will get the notification. One more thing about this video. I have prepared some notes for you. Those who want these notes, kindly comment in the comment box. Before we begin, I have a request. All the students must keep a modern periodic table with you. Then my explanation will be more clear for you. So we'll start with modern periodic law. The modern periodic law states that properties of elements are the periodic functions of their atomic number. But you know what Mendeleev told? Mendeleev told the properties of elements are the periodic functions of their atomic mass. And later on, what happened, you know? There were many drawbacks for Mendeleev's periodic table. So the most important scientist in the field of chemistry, Henry Moseley, he said it is not atomic mass, it is atomic number that determines the properties of elements. From this modern periodic law, the modern periodic table, that is called long form of periodic table, has generated. So don't forget about the father of modern periodic table, that is Henry Moseley. Now we are going to study about the characteristics of modern periodic table. You know that the periodic table has so many grids or matrices. 7 periods are there in our modern periodic table. So periods means the horizontal rows present in the periodic table. There are 18 groups, 18 vertical columns in the modern periodic table. If we check the modern periodic table, you can see 1 to 18 groups in that. Further divided into 4 blocks. On top of each block, it's written very clearly S block, D block, P block and F block. F block, you can see the bottom of the periodic table. First, I'm going to explain about groups. So the first group is called alkali metals. There you can see many metals starting from lithium, sodium, potassium, rubidium, cesium and francium. Now when you move to the second group, they are called alkaline earth metals. You can see there beryllium, magnesium, calcium, strontium, barium and radium. The first group and the second group together known as S block elements. Because when you write the electronic configuration, the subshell electronic configuration, the last electron of these two group metals are going to the S subshell. That's why they are grouped under S block elements. Now we'll see what are the general characteristics of these elements. These elements means the first group and second group together we are discussing. Generally, these two group metals are soft metals. You know that sodium, lithium and all, we can cut with a knife. Potassium, we can cut with a knife. Second point, they are very good reducing agents. Reducing agents are substances which brings reduction but itself get oxidized. So metals can be oxidized easily, meaning it can lose its electron easily and become positively charged ions. So from zero oxidation state, they are coming to the plus oxidation states. meaning there is an increase in oxidation state. That process is called oxidation. Third point, they generally forms ionic compounds, but exceptions are there. Lithium and beryllium, these two are the first members of each group. They normally form covalent compounds. The fourth point is these metals are highly reactive. You cannot see these elements in their free state in nature. Always they will be in combined form. You know the reason why they are highly reactive. The fifth point will support the statement. You know the fifth point I have written here is oxidation state of group 1 elements, that is +1, and oxidation state of group 2 elements is +2. For example, group 1 elements, lithium and sodium. Lithium, you know, atomic number is 3 and the electronic configuration is 2,1. Sodium, it is 2,8,1. You know that to get the stability, lithium will lose its 1 electron and attain the duplet, meaning K shell is completely filled with the 2 electrons. Sodium has the tendency to lose its last electron, that 1 electron, and attain the octet. Likewise, when you move to the group 2, you can see beryllium is the first member, atomic number is 4, 2,2. Definitely, this will lose these two electrons, and attain the duplet. Magnesium, 2,8,2, the last electron will be removed easily to attain the octet configuration. So you understood they are highly reactive because they need to attain stability. For that, they will always lose electrons. Group 1 will lose 1 electron, group 2 will lose 2 electrons. Now, highly electropositive. What was electropositivity? Tendency of an element to lose electrons and become positively charged ions. Next point, that is the 7th point. They have low ionization energies or ionization enthalpies. First we'll see what is ionization enthalpy. What is ionization enthalpy? IE, generally we represent it as IE. What is IE? What is ionization enthalpy? It is the energy required to remove an electron from the valence shell from an isolated gaseous atom. Meaning, you take an atom which would be isolated from other atoms and you try to remove an electron from its valence shell, meaning the most loosely bound electron. For that process, how much energy you have to supply? That is called ionization enthalpy. So the point written here is they have low ionization enthalpies. They have low ionization enthalpies. What is the meaning of that? The energy required to remove an electron from the outermost shell of group 1 and group 2 elements is very small. Small quantity of energy is required. What is the reason? You know that when we move from left to right in a periodic table, their size decreases. Size decreases means the attraction between nucleus and the outermost shell increases or outermost electron increases. It is difficult to remove that electron once the attraction increases. So here I have written size decreases when we move from left to right in a periodic table. Size decreases, attraction increases, hence difficult to remove the electron. So what will happen when we move from left to right? The ionization enthalpy increases. And you know your group 1 and group 2 are placed in the extreme left of a periodic table. Now the 8th point. Generally, they have low melting point and boiling points. Then, the electronic configuration. This part is very, very important. The electronic configuration. I have written here the general electronic configuration is NS1 to 2. NS1 to 2. What is the meaning of that? We'll discuss that in detail. Group 1, the configuration is NS1, and group 2, it is NS2. What is the meaning? Its last electron is going to the s orbital or s subshell. Only one electron is there in the last shell. That will go to the s subshell. Here there are 2 electrons that will be accommodated in the s orbital. That's why group 1 and group 2 together known as s block elements. Now in detail, what is this NS1 to 2? Meaning N is the principal quantum number. We studied this in the 2nd chapter, principal quantum number. That means it indicates the shell, which shell the electron is present. So 1 means it is K shell, 2 L shell, 3 M shell, and 4 nth shell. If you take sodium, you know, if you take sodium, what will be the electronic configuration? It will be 1s2, 2s2, 2p6, 3s1. If you take magnesium, group 2, it will be 1s2, 2s2, 2p6, 3s2. So the last electron is going to the 3rd shell and s subshell, and 2 electrons are accommodated in the case of magnesium. So that's the end of modern periodic table part 1. If you find it really useful, kindly subscribe my channel. More videos I'll be uploading. Part 2 will be releasing soon. Thank you.